Good morning, everyone. I hope you are staying dry and safe as we batten down the hatches for Hurricane Irma. Since your test has been postponed due to no school today, I figure that's the best time to get in a good study for it, some extra time. So let's go ahead and discuss your test. So one of the first things that's on it and that you'll see the most often is density. Now, density refers to how tightly packed matter is in a substance. And you should have um, a piece of paper and pencil in front of you, because if I'm writing this down, it's probably a good idea for you to write it down. And research shows that writing things down can help really cement them in your brain. So density, how tightly packed matter is in an object. Now remember, matter is anything that has mass or volume, and it is also made up of tiny things called atoms. So you're made of atoms. The chair or bed or floor or car that you're sitting in right now is made up of atoms. Everything around you, the headphones you're listening to me on, made up of atoms. So it's all matter. It all has a density. And the units for density are grams per milliliter or grams per centimeter cubed. And the only difference is their unit of volume that it was measured in. Now, the density of water, this is something you should know, is 1 gram per milliliter. And this helps us determine whether or not something floats or sinks. If I have a density that is greater than 1 gram per milliliter, that means I'm going to sink. Okay, but if my density is less than 1 gram per milliliter, that means I'm going to float. So any of your pool toys or styrofoam noodles, things like that, those all have a density less than 1. But any rocks, jewelry, things like that has a density greater than 1, and they sink to the bottom of something filled with water. Mass. Mass is the amount of matter in a substance. It's similar to weight, but not quite the same. And its units are grams. And you'll see over to the side here, I have drawn this lovely scale here for you to see. The instrument we use to measure mass is a scale, and you've used these many times in class. We've gone through, we've weighed objects, we've used weigh boats. Remember, nothing belongs on the scale unless it is a weigh boat or a piece of glassware. Do not put powder directly on the scale. Do not put any object directly on my scale unless it is a weigh boat or a piece of glassware like a graduated cylinder or an Erlenmeyer flask or a beaker. Okay, we never weigh things directly, but instead we use the 0 button to eliminate the mass of the container that we are weighing our objects in. Now, volume is how much space the object takes up. So something could have a very large volume or very small volume, and that will change its density, because if I have a large amount of mass, a large amount of matter, and it's only in a tiny amount of space, then that will be tightly packed. Now, the volume units, there are 2 of them, which we saw in density. One could be milliliters, which is used when we are using a graduated cylinder and we're measuring either volume of a liquid or volume of an irregular shaped object, or centimeters cubed. So let's talk about when you would want to use both. So one of the first ways is that we know that volume is equal to length times width times height. Now this would be if we had a rectangular object. So if we had something kind of like this, okay, where our length would be here, our width would be along this front to back, and our height would be how high the object sat off of the table. And we would measure them using a ruler in centimeters. And so when we would get a number in centimeters times a number in centimeters times another number in centimeters, we would get centimeters cubed. And the reason why it's cubed is because we have 3 different numbers with centimeters that we measured. If I multiplied centimeters 4 times, it would be centimeters to the 4th. I don't actually know how to say that beyond cubed. Another way to measure volume is just using a graduated cylinder. And this is for liquids only, okay? And this would measure in milliliters. Remember that milli means 1,000, and so 1,000 milliliters are equal to 1 liter. So in your liter of soda, there are 1,000 milliliters. Now, another way to measure volume is through a method we have talked about multiple times, water displacement. You've also done this multiple times in class. We did it in the aluminum foil lab, we did it in our measurement lab, we've done it in our ADI lab that we just finished on A-Day. We've done it multiple times, but it uses a graduated cylinder. So if we have a graduated cylinder here, okay, there's the base, okay, and initially what happens is we have a water level, okay, and we take our initial reading. So our initial reading, let's say this is 10 milliliters, okay, and then what happens is we drop an object in. And this object has a weird shape. It might be a ring or a circle, sphere shape. It might just have something that can't be measured directly using length times width times height. And when we add an object in, the water level goes up. And so when it goes up, our new reading might say 15 milliliters. Now, we know the object's volume is not 15 milliliters because the 15 milliliters is equal to the 10 milliliters of my water plus the amount of volume of my object. And so what we do is we subtract these two numbers to get the volume of my object, and 15 minus 10 would be 5 milliliters. And so we use the displacement of water to determine the volume. How much water did it displace or move in order to be there? Now, this would only work for objects that has a density greater than 1, because if we were to put it in water and it floated, we wouldn't really be able to get an accurate volume for it. So now that we've talked about the 3 different ways to measure volume, we've looked at mass and things of that nature, let's go ahead and start working on our density formulas. So density, as we are all aware, is mass divided by volume. Now, you might see this little triangle over to the side, and I didn't teach you this method in class because it's really not my favorite, but if you're still having trouble with these density formulas and we're getting down to the wire, your test is coming up, you just need a shortcut, then I guess this is for you. If you put mass in the top part of the triangle and density and volume on the bottom, and you draw this triangle on your test, you will always, always, always be able to get the correct formula. And the reason why is if you cover up density with your hand on the triangle, you will find that you only have mass over volume left, and that's the formula. If you cover up mass with your fingers, then you have density and volume side by side. And any number that is side by side is multiplied by each other, and anything that's top and bottom would be divided by. So we can use this to get our formulas. Mass is density times volume, and if we cover up volume, the V for volume with our fingers, we have mass divided by density. And so this allows us to get our formula very quickly. Now, you might also see this rectangle of multicolors over here on the left of your screen. And what this is a density column. I just really like using the rainbow and night sky and gold shimmery colors to do it. Now, if we have three different liquids, so if we have liquid A, B, and C. Liquid A has a density of 0.84 grams per milliliter. Volume or liquid B has a density of 1.00 grams per milliliter, and object C has a density of 2.5 grams per milliliter. We would need to decide, okay, which of these three liquids would be in our column and how would they be arranged. Now remember, if an object had a density greater than 1, it sank. And so this tells us that if I have a really heavy density or really high density, that it would be at the bottom. And so that means this rainbow one would be object C. Now, liquid C. Liquid B has a density of 1.00 grams per milliliter, which is the density of water, so it's most likely water, and it would go in the middle. Okay, and that's because it's lighter than liquid C, so it would float on top of it. And then liquid A has a density of 0.84, which is the density of rubbing alcohol, and it would float on top of all of that. Now, if I were to add some liquid C, it would sink to the bottom until it got to where it met up with the rest of its liquids that was similar to it. And so let's take our formulas and let's do some practice problems. In order to do these practice problems, you're going to need two things in front of you. Your calculator, which I have told you you will need every single day for the entire school year. We are 5 weeks into the school year, and there is no excuse to not have one. So let's look at practice problem number 1. I recommend pausing the video in order to write down the problems before you do so. So go ahead and pause, take your piece of paper, write down your problem, and then we'll work through it together. Okay, now that you have written down the problem, let's go ahead and analyze this question. Our first step is always going to be to read the question completely before doing anything. So Sally was given an object with a mass of 45.0 grams and a volume of 37.5 centimeters cubed. What is the density of the object? So I saw that we were given two numbers. We were given 45.0 grams, which regardless of what the words say, anytime I see the word grams, I know that this is going to be my mass. And I saw that I have 37.5 centimeters cubed. Centimeters cubed is always volume. And so it asks, what is the density? That's my question mark. What am I trying to find? And so we write down our givens first. Remember, in class we learned about the guess method. Given, unknown, equation, substitute, solve. If you follow that method every time, you will be golden for your test. So first is our givens. We know that our mass is 45.0 grams. Our volume is 37.5 centimeters cubed. So we have our givens. Our unknown is what we're looking for, and our unknown is our density. So we have our given, our unknown, our equation. Now our equation for density is going to be density equals mass over volume. We're going to substitute our numbers in. So we have 45.0 grams divided by 37.5 centimeters cubed, and we're going to solve. So this is where we take out our calculator, and we always make sure to put the number in our numerator or the number in the top of our fraction in our calculator first. So 45.0 divided by 37.5 will give us 1.2, And our units do not cancel out because they're not present on both the top and the bottom. So I just rewrite them the way they are, grams per centimeter cubed. Now, before we can say that this is our final answer, we have to look at significant figures. So remember, significant figures tell us and help us keep track of how accurate or precise, well, not how accurate, but how precise our instruments were when we were measuring these things. So the rule for multiplication and division, anytime you do a multiplication and division problem, is the least number of significant figures. So 45.0 has 3 significant figures. 37.5 has 3 significant figures. So our answer should also have 3. However, right now it only has 2 significant figures. So I need to decide, what can I add to my number in order to make it have a 3rd significant figure without changing the number? And that would be a 0. So my final answer would be 1.20 grams per milliliter. And I would box that in. So, excellent. Why don't you pause the video, write down question number 2, and go ahead and give it a shot. Try it on your own and then come back to the video and we will work through it together. So go ahead, pause, write down the question, work it out, following the guess method, and then press play and we will go over it together. Okay, so what is the mass of a 25 milliliter object with a density of 2.7 grams per milliliter? Remember, first thing we're going to do is we read through the question, and now we're going to go back and look at what we are given. We are given 25 milliliters, which that means milliliters is always volume, with a density of 2.7 grams per milliliter, so that's density, and it says what is the mass? So mass is my question mark. So we're going to write down our givens. We know that our volume is 25 milliliters. Our density is 2.7 grams per milliliter, and our unknown in this case is mass. Now, with our equation, we have our given, our unknown. The next step is E for equation. We're going to come back up here, and we know that if I cover up mass on my triangle, then I get density times volume. And so the formula I'm going to write down is mass equals density times volume. And I'm going to substitute, so given, unknown, equation, substitute. So 2.7 grams per milliliter times 25 milliliters. Okay, now when I look at this, I have milliliters in 2 different locations, and one is on the bottom of the numerator and one is on the top. And so they are going to cancel out, and all I will have left is grams. And when I solve this, 2.7 times 25, it gives us 67.5 grams. But again, we need to look at significant figures. So 2.7 has 2 significant figures. 25 has 2 significant figures. So my answer should only have 2. Right now, though, it has 3 significant figures. So what we do is we look at our first 2, 67, and we say, does the 0.5 make 67 round up or stay the same? Now remember, the rules for rounding, if it's 5 or higher, we round up. If it's less than 5, it stays the same. So my final answer will be 68 grams. Well done. Let's go to problem number 3. Which, by the way, there will be 4 practice problems here, in addition to the problems that you have on your note sheet, on your study guide. Remember, all those things are due tomorrow for your stamps. So let's look at problem number 3. You can pause the video and write down your question. So Carlos has a metal box with measurements of 18 centimeters by 4 centimeters by 6 centimeters. The mass of the box is 40 grams. What is the density? Now, with this, we see that I have centimeters and centimeters and centimeters, okay? So that tells me that I'm going to need to use my formula, volume equals length times width times height. Okay, now I don't care which one is length times width times height because I'm multiplying them all, so it doesn't really matter. And I also see that I have 40 grams, which is my mass, and my density is my question mark. So let's go ahead and solve for volume first before I write down my other things. So I know that I'm going to have 18 centimeters times 4 centimeters times 6 centimeters. Now, when I do this in my calculator, 18 times 4 times 6, I get 432 centimeters cubed. Now, I need to look at my significant figures. When I'm multiplying, I keep the least number of significant figures. So 18 has 2 significant figures, 4 has 1, and 6 has 1. So that means my answer should only have 1, but right now I have 3. So I'm going to look at my first significant figure, which is the 4, and I'm going to change the other 2 to zeros without a decimal so that I only have 1 significant figure, but I still keep the fact that my number is a large, it's 400. And now I'm going to jump into the rest of the problem. So I know that my volume is 400 centimeters cubed. I know that my mass is 40 grams and that my density is my unknown. So now that I've got my given, my unknown, my equation, density equals mass over volume. The mass is 40 grams. The volume is 400 centimeters cubed. And we solve. 40 divided by 400 is 0.1 grams per centimeter cubed. And we look at our significant figures. 40 has 1 significant figure, 400 has 1 significant figure, because remember, these zeros at the end do not count unless there is a decimal place. So my answer should only have 1, and it does, because the 0 in front, leading zeros never count. So this is actually my final answer. Now, we're going to move on to question number 4. Now, when we look at question number 4, it's kind of long, and you need to get used to questions like this on your quiz or on your test. So let's go ahead and pause the video, write it down so that you can be working alongside me as we go, and then press play when you're ready to go over this problem. Okay, so let's read the question first. Juan was working on a laboratory experiment to determine the density of an unknown object with a weird shape. He decided to use water displacement to determine the volume. The initial volume of the water was 25.0 milliliters. After adding the 2.78 gram object, the water rose to 30.2 milliliters. What is the density of the unknown object? Okay, so now I'm going to go look at my numbers and see what I have. So I have 25.0 milliliters. Milliliters tells me that I have a volume. After adding the 2.78 grams, grams is always mass, the water rose to 30.2 milliliters. I have a second volume. Okay, what is the density of the unknown object? Density is my question mark. So here, they mentioned the word water displacement, and they also gave me 2 volumes. Now remember, in order to solve water displacement, if we go back up to our notes about it, we'll see that it is, my screen appears to not want to scroll. There we go. If we go back up to water displacement, we know that we put it in a graduated cylinder, the water level rises, and we subtract our 2 volumes. And so when we're looking at this problem, our volume, we're going to need to figure out our final volume minus our initial volume. So we see that the initial volume of the water was 25.0 milliliters. So that means that's V initial, and the second one is V final. So we're going to take 30.2 milliliters and subtract 25.0 milliliters. And when we do that, 30.2 minus 25.0 gives us 5.2 milliliters. Now you might be asking me, Miss Nichols, do I have to write down 25.0? Can I just write down 25? And the answer is no, because your graduated cylinder was able to measure to that tenths decimal place. And that's very important because it tells us the precision of our instrument. And it will affect our significant figures because when we subtract numbers, we use the lowest number of decimal places. Now, both numbers have one number after their decimal, which means my answer should only have one number after their decimal. And so that is why it's important, because if I just wrote down 25, it would look like I only have 0 decimal places, and my answer would be 5 instead of 5.2, and that could really change some of our math later down the line. Now we also know that our mass is 2.78 grams, and that density is our question mark. And so we've got our givens, our unknowns. Now let's put our equation. Density equals mass over volume. The mass is 2.78 grams. And the volume is 5.2 milliliters. And so when we do this, we say 2.78 divided by 5.2, and we get, in our calculator, a lot of numbers. We get 0.534615385 grams per milliliter. And you say, Miss Nichols, I know you don't want me to write down all of those. And the answer to that is you're right. I want you to use your rounding rules based on significant figures. When I'm multiplying and dividing, it's the lowest number of significant figures. So our numerator has 3 significant figures. Our denominator has 2 significant figures. So my answer should only have 2. That's the lowest number. The 0 does not count, but the 5 and 3 does. So I'm going to keep the 0.53 and I look at the 4. Does the 4 make the 3 round up or stay the same? It stays the same. So my final answer should be 0.53 grams per milliliter. Now, this is going to be the conclusion of our first video. This is review part 1 because density just takes a long time. So I'm going to go ahead and upload this to the YouTube video and you can begin watching it while I create the next one. Good luck! And send me a message on Remind if you have any questions about things you saw on the video.